Why you keeping me waiting? Been so long. Why you keeping me waiting? All I
Prepare to experience the strongest radio allowable by law. Secrets will be revealed. Myths dispelled. From the studio gym where excuses never apply, it's Superhuman Radio with your host, Carl Lenore.
Hey, welcome back to another episode of Superhuman Radio. We have a fascinating show for you. We've talked for a long time about senescent cells. I actually did my very first show on senescent cells around 2008 after a study was published. I feel like it was the Albert Einstein School of Medicine. I can't remember now. That showed that cellular senescence was triggered by glucose signaling. And it's a fascinating concept, especially when you look at the amount of type 2 diabetes and insulin resistance we have in our population today, and probably a great contributor to cellular senescence and their accumulation. And when you look at a lot of the drugs that are coming out proclaiming to be good for cellular senescence, many of them simply help you manage blood sugar better. Now, do they get rid of senescent cells? Even Dr. Blagascloni was hard-pressed to give me a straight answer on rapamycin. And I said, well, he started talking about quiescent cells and senescent cells. And I said, but does it vanquish them? Does it get rid of them? And my recall of the discussion was not that it got rid of them. So something that actually gets rid of senescent cells is really, really important. Now, we know exercise does. We've talked about those studies in the past. But there is actually a metabolite present in your body right now that has the ability to get rid of senescent cells. And when you think about the race to find senolytic drugs, and you find out there's actually something that occurs in your body naturally that has the ability to do this, you have to ask the questions: A, how do I harness that and make more of it? B, how can I improve the production of these metabolites? And we're going to get to those questions and more in just a moment with my guest. Before we start, I have to thank our title sponsor, and that's Legendary Foods, for the making of the tasty pastry. It started out as a Pop-Tart, and it's so much more, less than 1 gram of sugar, 4 to 5 net carbs if you're a low-carb person like me, 20 grams of high-quality protein. But the important thing about the tasty pastry is they taste amazing. They taste like you're eating real cake. So much so that your children will eat them. You can't get your kids to eat a healthy protein bar, but you will have to wrestle these away from them because they'll eat them all the day they come in. Go to shrnetwork.biz/legendary. Use the code SHR10 to save 10% off. Their hashtag is better than a protein bar, and it absolutely is. Check them out. You'll love them. You'll be happy you did. And now let me bring my guest on. Dr. Simon Melov, welcome to the show, sir.
Happy to be here.
So you heard my little discussion and my introduction about the race to find senolytic drugs. It's a very, very popular area of medicine today, isn't it?
Yeah, it is. And I think that's because there's been a steady drumbeat of breakthroughs in understanding how these cells, which are sometimes called zombie cells, can mediate many of the degenerative changes associated with aging. And so I think maybe over the last 20 years or so, there's been this steady publication stream. First of all, understanding it in cell culture models, then the role of senescent cells in different types of mouse models of degenerative disease, and then finally demonstrating that these cells are present in our own bodies as we get older. And now there are very large-scale efforts underway, of which we're part of that, actually, at the Buck Institute, to map these senescent cells in multiple tissues of the aging human body.
Are senescent cells in various tissues different? Say, the senescent cells you find in, let's say, muscle tissue versus the senescent cells you find in pancreatic tissue. Are they different, or are they the same senescent cells?
So to put a qualifier on that question straight away, we don't know, but we think so.
Okay, that's fair.
So I think most of the sort of consensus thinking around this is that senescent cells are different depending upon where they are, what species you're talking about, what tissue you're talking about, and even the sort of the detrimental effects where they secrete a lot of pro-inflammatory cytokines. Vary by site in the body, they vary by tissue in the body. The exact extent and quality of those differences is what's being mapped and studied at the moment at a very high level under a program called SENNET, which is part of the Human Biomolecular Atlas program, which is a large-scale effort across many sites in the country and, in fact, the world, to map cells in the human body. And our particular effort in SENNET is focused on senescent cells in the human body.
So let's talk about your discovery. What is this compound, this metabolite, that seems to have a senolytic effect in humans and rodents, obviously, but in humans as well?
Yeah, so 25-hydroxycholesterol is an endogenous metabolite in the cholesterol sort of pathway. Its functions, in a general sense, are not particularly well understood. I would say that's true. It seems to participate in multiple different pathways involving inflammation. It's produced naturally in varying levels in different tissues in our bodies. It's not, as I said, very well understood in terms of how it mediates these beneficial effects, but we found that it actually is a fairly potent substance for killing senescent cells, both in culture and in mouse models. And we found it. We actually characterized it across, I think, about 8 or 9 different cell types in 2 different species, human and mouse.
Okay, and so 25-hydroxycholesterol is manufactured in the body naturally as one of the oxysterols that we possess. Obviously, the sulfated version as well, which seems to be very interesting as well. And so they have been termed repair regulators for some reason. So aside from senescent cells, what else do we know about them right now? Do we know what they do in other repair mechanisms?
Well, I'm not the best person to ask about the deep history of the particular molecule. I mean, we really discovered it serendipitously as a molecule which kills senescent cells, because that's what we were looking for. So I don't have a deep history of the molecule itself. So probably not the best person to ask for that.
When a senescent cell is killed,
what
happens? Do we have a cleanup process like we have with other cells that go through apoptosis? What happens to senescent cells when they kill them with the 25-hydroxycholesterol?
Yeah, that's a great question. For like in vivo action, I don't think we really know. What happens. We're looking at whether or not, for example, autophagy markers are upregulated in conjunction with 25-HC treatment to see if the dead cell is sort of tidied up by autophagic processes.
Yeah, right. Exactly.
Yeah. But we don't know on that. In a more general sense, I think when senescent cells die, they do release unique substances into the circulation. And one of those things actually is a biomarker for the level of senescent cells being killed. And this is something which was discovered by my colleague and friend Judy Campisi, who's sort of one of the leading lights in senescence biology. She's also at the Buck Institute. And her and a postdoctoral colleague published a paper last year demonstrating that you could track the level of senescent cell death in vivo by measuring this biomarker, which is secreted into the plasma and urine. And this is a biomarker called 15-DPG-J2. Don't ask me the full name because it's some great long, huge thing. But in any case, as this level of senescent cells is being killed, they're releasing this biomarker specifically into the circulation, which you can then pick up with a simple blood test. So this is a real game changer with regards to evaluating the efficacy of potential senolytics, because you can give a senolytic and then you can measure whether or not senescent cells are being killed in the individual without having to do anything terribly invasive other than a blood test or a urine test. And so we used that biomarker to evaluate the efficacy of 25-HC in killing senescent cells in both old mice as well as in a variety of other models. So it's a pretty good tool for evaluating whether or not you're killing senescent cells, and then you're measuring this metabolite which is released just from senescent cells. It doesn't occur anywhere else.
So there is a couple studies that show that senescent cells carry 2 to 3 times more iron than quiescent cells.
Right.
And there's a lot of discussion whether iron contributes to the development of senescent cells, or whether it's the senescent cell is like a cancer cell. It's hungry. It tries to capitalize on everything that will help it survive. But when the senescent cell is killed, I would imagine this high level of iron that would then be released into the other tissue and bloodstream would spark an increase in ferritin production from the liver to respond and bind that free iron up, because the body knows that free iron is the most damaging to the body.
It's bad. Yeah,
sure. Is there any evidence that when these quiescent cells are killed, that this iron is released and then handled somehow by the body?
That's a great question. I don't know of any specific study which has looked at that. Unfortunately, when you're talking about metallochemistry in vivo, it's exceedingly difficult to do those studies with a high degree of precision, which is what you're asking. For example, ideally, you would be able to detect the iron in a single cell, see and track that iron as it was released from that cell as it died, and then see the compensatory response of the defense mechanisms around that. It's hard to imagine how to do that in an in vivo situation. I can see some ways you could do it in a cell culture situation, perhaps, but then you're not going to get the defenses being upregulated because it's just cell culture. The other part of this, which is difficult, is in general, senescent cells only occupy about maybe 1% of the tissue. Right, they have they punch way above their proportion though, because they're deleterious. They're secreting these inflammatory factors all the time, or a lot of the time, and that sort of belies the fact that they only make up 1% of the tissue, and that may vary depending on the tissue, by the way. But it's rarely going to be more than like maybe 5% at most. And this is, again, coming back to the SenNet project, what we're trying to evaluate and quantitate how many senescent cells there are in multiple different tissues in the body. But it's just difficult to measure single cells or very small proportions of cells in tissues with the kinds of experiments you're talking about, because how do you quantitate such a small thing in the overall sort of volume of blood, right? I mean, it's just really tough.
Yeah, I get that. So senescent cells, would senescent cells be categorized as cells that lived past their expiration date? They avoided the apoptotic landscape that should have occurred, and they're zombie cells. And if so, do they share any similarities with cancer cells?
Yeah, I think a lot of the early work on senescence was actually congruent with a lot of the sort of the fundamental cancer studies. In fact, if you look at most people who've been working on senescence for a long time, they came at it from a cancer angle because that's where the start was. In fact, Judy Campisi, my colleague at the Buck, that's what she started as. She started as a cancer biologist. So I think that's true. But the definition of a senescent cell, which is this fundamental arrest in replication, is founded in a lot of these early cell types, which were very, very popular to study senescence and make these fundamental insights into. And now that definition is starting to shift. There's an increasing interest in looking at, for example, potential senescent-like states in post-mitotic cells, which, bear in mind, post-mitotic cells make up most of your body. It's not mitotic cells make up most of your body, it's post-mitotic cells. So the fundamental sort of canonical definition of a senescent cell is that it's an irreversible, halt in cell replication. And for post-mitotic cells, that's already happened. They don't divide, right?
Right.
So how can a post-mitotic cell be called a senescent cell? And so there's a lot of people now investigating how even post-mitotic cells can have a senescent-like state. So that the definition of senescent cells is starting to shift. It's starting to encompass multiple different cell types. It's growing and expanding, which is what you would hope for in science. We don't just like stake our flag in the sand and stay there. It's always moving. The goalposts are always moving. So that's what's happening with senescence.
What role does insulin play? And do you think, or have you read from other works, what role does insulin play in the development of senescent cells? As I said earlier, the first show I ever did that the word senescent cell came out it showed that glucose signaling made cells senescent. We're talking about a rapid rise in blood sugar or these constant spikes in blood sugar. Does insulin play a role in the development of senescent cells, you think?
Well, energy balance in general is sort of fundamentally tied up with a lot of processes of aging. And senescence is a process of aging. So there likely is some relationship. I'm not sure I've read of anything which directly ties insulins to producing senescent cells in the way that you're talking about. Generally speaking, senescence has a variety of different routes which can be traveled to arrive at being, senescent, right? And a lot of those are things like genotoxic damage, some other type of stress. There are multiple different routes to arrive at being senescent, and many of these routes encompass other pathways which are associated with deleterious processes of aging. So insulin is such a broad acting kind of like thing. It's hard to sort of like say, well, this is the route where this happens, and this is the pathway we must follow. There are many pathways to becoming senescent, and it's likely insulin is involved in some, if not all of them.
25-hydroxycholesterol is the precursor to cholecalciferol production in the skin from photoactivation, and the sulfated version makes 25-hydroxysulfate, vitamin D sulfate. Is there a relationship between sun exposure and you think 25-hydroxycholesterol, since it's such a hugely important donor to the production of vitamin D, and vitamin D has played such a huge role in our evolution, and obviously the sun at the work of the sun. Is there anything interesting about how the skin uses 25-hydroxycholesterol that would imply the more sun you get, the more 25-hydroxycholesterol you have?
Well, we haven't looked at skin at all in our studies to date. I mean, we have worked with some fibroblast cell types, which are of course, present in skin, but we haven't looked at the role of 25-HC in skin as a sort of a tissue of interest. Most of our work has been focused on muscle, so that's what we've really been looking at. But of course, the sun plays a major role in inducing damage in the skin. And we know, that the photoaging is called that because the sun accelerates the aging process in the skin. And anyone who's looked at sun exposed versus non-sun exposed skin knows that in 30 seconds. I mean, there's some great pictures of truck drivers who've like done the same route, and one half of their face is like sun exposed and the other half of their face is not. And one half of their face looks young and the other half of the face looks old, so it's a very potent inducer of sort of aging effects, and that includes in inducing senescent cells. So one would imagine, and I'm not aware of this pathway which you're talking about. So one would imagine that there's some interplay there, but we haven't looked at it at all. So.
I'm a sun worshiper, and I'm a huge believer that our avoidance of the sun is creating more problems than the potential wrinkly skin that we, from a social standpoint, we're so afraid of getting. The sun influenced us and our evolution, and we can't just discount that and go, oh, well, now we just need to slather, sunscreen on ourselves because things are different. Things aren't different. The food we're eating is different. And in my humble opinion, that is the contributor to skin cancer, because many studies on skin cancer look at the retinol content of tissue and its relationship to protecting against skin cancer. And people who have high levels of vitamin A, real A, not the carotenoids, that retinol in their skin, they don't develop the skin cancer from the sun. And those cases of the most aggressive skin cancer, they seem to have virtually no vitamin A in the skin. And we also know that sun depletes vitamin A. So, I am always cautious to blame the sun for the things that we're seeing today in modernity, any more than I would say that book of matches started a fire. No, someone struck that match and put it to the curtains, and that started the fire. I strongly believe that the sun is an unwilling participant in the things that we hate about the sun right now. But that's just my own. I'm not a doctor. No one can threaten to take anything away from me. So I can say things like that and stay at arm's length from it. But I just want to put that out there because I'm a firm believer that the dermatological doctors today are doing us a great disservice, telling us, don't get sun, stay away from sun, it'll age your skin. My face looks like an old shoe. I'm proud of it. I'm proud of it because I'm 63, I'm strong, I continue to build muscle and strength, I'm healthy, I sleep well, I eat well, I have great bowel movements. I mean, I have all the hallmarks of a healthy person, and I lay in the sun at every chance I can, but I do supplement with retinol. I will say that. Okay, so now let's talk a little bit about other things that interplay with this discussion, and that is exercise. There's a lot of good research, and you and I talked about it off the air, that shows that exercise removes senescent cells from the body, correct?
Well, I would say it's early days yet. I think some of these studies are intriguing, sort of, as I like to say, first flags in the sand. But there's no sort of like take-home message here yet. But there is certainly some intriguing preliminary data suggesting that exercise can remove senescent cells. But it's very early days yet. We're just beginning to get our arms around this very complex problem of senescence. And as I was saying earlier, we don't even know how many senescent cells we accrue in each tissue as we get older, nor which tissue is most prone to accruing senescent cells with age. There are a lot of studies showing the presence of senescent cells in different tissues in our body, but the quantity, the variation of those senescent cells, still very much an open question, and it's something which I think there's a great tool set which we can now use to quantitate this and evaluate this, and that's in large part what this big proposal or big program which we're involved with called SenNet is going to do over the next 5 years.
You can't really talk about inflammation without talking about the gut. Because through the immune system, which, the gut, whenever I talk about the immune system on the show, I remind people we're talking about your gut now, because a lot of people don't make this they think the immune system is some amorphous thing that is around the body, kind of, we can't put a finger on it, but 80% of your immune system is in your gut. Is there any relationship between senescent cells and gut?
Well, again, it's another one of these situations where I think there's some very intriguing papers out there which have shown some interesting links between gut inflammation and different signaling to different tissues and things like that. But I don't think we're in a position yet to be able to say, well, if you eat this, this is going to do this to your immune system. In a way which is sort of really rigorous at this point. And I think, the tools, the technology which we have now for investigating this is allowing us to ask and answer these questions finally. I mean, many of the questions which we've been sort of loosely discussing here, we've been asking for 30 years, but we haven't had the tools to do it. And the tools are now just crazy. I mean, we can sequence single cells very easily now, thousands of them. And in my lab, we're doing this routinely. And that's something that even 5 years ago would not have been possible. And so the volumes of information which are coming out of these new technologies being applied to problems like senescence and signaling from different tissues, gut being one of them. This is really an exciting time for science, I think.
I think so too. I want to plug your lab real quick. You're located at the prestigious Buck Institute. That's in California, right?
Yeah, we're about 45 minutes north of San Francisco, and I think we're still the only sort of not-for-profit research institute in the US focused solely on aging and age-related disease. So, we've got a small faculty, but we try to work very hard in a collaborative way to leverage everyone's research so that, rising tide floats all boats type thing,
The Melov Lab is the first independent biomedical research institute in the world focused solely on aging. If you want
No. That's the Buck Institute, not my lab.
Okay. I'm sorry. Okay. My mistake. But okay, so the Buck Institute is of which the Melov Lab is a component of.
Yeah,
you
correct.
By going to shrnetwork.biz/Melov, MELOV, if you want to learn more about what they're doing there. We're going to take a quick commercial break. I've got lots more questions when we come back. Stay with us. We're talking with Dr. Simon Melov from the Buck Institute Melov Lab, and we shall return shortly. If you've listened to Superhuman Radio for any length of time, you know I'm a big proponent of peptides. One of my favorites is GHK-Cu, the blue copper peptide. It has the ability to repair and regenerate more youthful expressions of skin cells, reversing the signs of aging. Restore Cell's Stem Cell Awakening Serum, along with their other products, contain potent formulations of blue copper peptide and only the highest quality organic ingredients. Superhuman Radio listeners can now save 25% site-wide. Buy their complete set and receive a free exfoliating cleanser. Go to shrnetwork.biz/blue and use the code SHR25. That's SHR25. Remodel your skin today. Plant medicine has become all the rage for mental optimization. Now there's an ancient plant medicine rapidly growing in popularity that experts believe might just be the alcohol of the future. It's called True Kava. Kava is a natural food-grade elixir that has been used for over 3,000 years by South Pacific Islanders as safe, non-addictive alternative to drugs and alcohol. By naturally boosting the brain's main feel-good chemicals, dopamine, serotonin, and GABA, Kava provides you with both increased relaxation and mental clarity at the same time. True Kava is a new form of stabilized full-spectrum traditional kava that is third-party lab tested for quality and safety. Go to shrnetwork.biz/true kava, and that's TRUKAVA, all one word, and use code SHR for 25% off today.
New Mass Pro Synthogen X2 just upped its own legendary game. To distance itself even further from the rest of the pack, Synthogen X2 now has double the key active ingredients. If you've ever wondered what steroid-like recovery feels like, Synthogen X2 delivers. See why others compare it favorably to powerful bodybuilding drugs at synthogen.com. Mass Pro Synthogen. When you train with it, you'll gain with it.
If you'd like a shortcut to better sleep, more energy, and calmer, more stable moods, then you should make sure you're supplementing with magnesium daily. Let me tell you why. About 75% of people are magnesium deficient. This deficiency can lead to higher levels of anxiety, irritability, trouble sleeping, and low energy. It can even contribute to foot and leg cramps while you sleep. Magnesium Breakthrough by Bioptimizers is the single best magnesium supplement in the world. Simply take 2 capsules before you go to bed, and you'll be amazed by the improvements in your mood and energy levels, and how much more rested you feel when you wake up. I take Magnesium Breakthrough every night, and I sleep better because I use it. Go to magbreakthrough.com/SHR and use the code SHR10 during checkout to save 10% off and get free shipping. Check it out. Are you 35 or older? Every year after puberty, your growth hormone decreases sometimes by 50% by the age of 35, and it only keeps going down from there. This affects everything from making it harder to recover from workouts, sleep, and a general loss of a sense of well-being. It also affects your ability to get and stay lean. BioPro Plus is the first of its kind, 100% non-synthetic alternative to prescription synthetic growth hormone treatments. All the benefits without any of the needles or side effects, and 100% safe. Previously only available through doctors, you can go to shrnetwork.biz/biopro, that's BIOPRO, and use code SHR30 for $30 off today. Remember those rectangular toaster pastries you used to love when you were a kid? Well, Legendary Foods has just made them better. The new cake-style tasty pastry is like nothing you've ever had before. With 20 grams of high-quality protein and less than 1 gram of sugar, you'll feel like you're cheating, but you're not. Go to shrnetwork.biz/legendary and use the code SHR10 to save 10% off your purchase of tasty pastries. Now available in cookies and cream, red velvet cake, birthday cake, blueberry, strawberry, brown sugar cinnamon, and hot fudge sundae. Go to shrnetwork.biz/legendary and use code SHR10 today.
Move over, superheroes. This is the Superhuman Channel.
Welcome back. We're talking with Dr. Simon Melov. We're talking about this fascinating molecule, 25-hydroxycholesterol, and how it may actually be its own senolytic. And I would imagine you're going to work on drugs where you can concentrate the amount of that you give somebody, right? That's the future of this right?
Yeah, we're looking into sort of trying to improve the efficacy of 25HC, using it as a tool compound basically to try and find better senolytics. It's pretty good. I mean, it works in mice, as we showed in our recent paper. It works in human cell culture. We're a long way away though from sort of like prescribing it as a drug or some better form of it as a drug. So.
It's fascinating to me that it's there already. It could be why some people age better than others. Maybe they make more of it, or the exchange rate between senolytic cells and it are more effective. But I got to believe that also there might be some people out there who don't produce enough. So I did a little research to look at the cytochrome P450 pathway, CYP27A1, which is required to make the 25-hydroxycholesterol, but is also the pathway that is disrupted by cholestatin drugs that are designed to reduce cholesterol levels. So I have to believe that, and this is me saying it, not you. I understand this relationship here, but I have to believe that people on statin drugs probably produce less than people not on statin drugs.
Yeah, I mean, one of the interesting things here, which, I mean, that's a really interesting point, and now I'll have to go look that up. But one of the interesting things about this molecule is that although we found it has a senolytic potential when we give it exogenously, and it works quite, as I said, quite well. When we give it to old mice or in cell culture, the production of that may be not linked in vivo to a senolytic action. So we may be producing it for different reasons, and it just happens that when you give more of it, it has a senolytic effect. But we haven't been able to establish whether or not it's working in vivo at endogenous levels as a senolytic. That's a great question, and it's one we're very interested in. And exactly what you were talking about, the levels of natural genetic variation between individuals. How much do they produce? Is there some sort of cycling component to this? Does it go up or down with age and different tissues? All of these things are questions we're interested in.
There were two studies produced by the University of Hawaii about a decade ago. And it took 10 years for other labs to start to look at it and reproduce the work, and it is reproducing. And that is in individuals 70 years and older, those with the highest total cholesterol levels live the longest. And this is well, the one that was done by Hawaii was very well controlled. And they had people who smoked cigarettes, but how their cholesterol levels predicted their longevity. And another study was just published recently, I want to say, if not last year, just this year, that came to the same conclusion. In elderly people, those with the highest cholesterol levels, and we're talking above 220, the doctors tell you, oh my God, your cholesterol's near 220. We got to get that down. And what we're finding out is that cholesterol is really a really important thing for the entire brain and everything.
Well, I think it'll depend on, as I'm sure you know, the ratio between the HDL and the LDL. If you can be high on one of those, and it's good, and if you're high on the other one, it's not so good. That's been linked to lots of bad things. So I think the totals is certainly interesting, but it's the ratio which I think
HDL to LDL.
Yeah.
So telomeres were all the rage 10 years ago, and we don't hear anybody talking about telomeres any longer.
More like 30 years ago.
Okay, but I mean, people were making supplements. TA65 came out. I want to say the last part of the name is membranaceous. I can't think of it. It's not, but anyway, there was a supplement that was being sold that was supposed to increase telomerase. There was lots of discussions. Well, telomerase isn't good because cancer cells overproduce it. Well, cancer cells overproduce everything that keeps them alive, and they harness everything that's good. But is there any relationship between telomeres and senescent cells?
Well, as I was saying earlier, there's many routes to becoming senescent, and replicative senescence is one of those routes, and that is actually a form of senescence which does involve telomeres. So there's no one simple answer for senescent cells, and telomeres, as you pointed out, was a hot topic, like I say, closer to 20, 30 years ago, science is a little bit like fashion. Things come back, so maybe telomeres will come back. Who knows? I mean, we've gone through several epochs. Currently, we're sort of coming out of the NAD epoch, and we're going into a different epoch, and the different epoch is regenerative medicine and stem cells. Reprogramming, that's very hot at the moment. Large amounts of money are going into it. For good reason. There's some real potential there. But science is a little bit, fashionable in some senses. People go where the impetus is, and to some extent where the money is. So what people so telomeres didn't pan out. They just didn't pan out. They like as a single solution for aging, they certainly didn't pan out. There's some labs have made some really tremendous strides in telomere biology and understanding its role in aging, and it does play a role in aging, but it's nowhere near the magnitude of what people originally thought.
Yeah. And they're very sad, all the money they spent on telomerase promoters. When senescent cells die off, if they die off rapidly, I know like there's a term called Herxheimer Effect, where if you kill off pathogens that are in the gut, they flood into the bloodstream, and the patient feels sick for a day or two, almost flu-like, and then it subsides because the body handles this stuff and gets it out. If you were able to kill off all the senescent cells, and I know you wouldn't want to, but if you were able to kill off all the senescent cells in my body, would I feel sick for a day or two?
Well, this comes back to the amount of senescent cells in your body. And this is something which we're trying to establish and trying to measure at the moment. We don't yet know the level of senescent cells for individual to individual. This biomarker I was talking about earlier, 15-DPGJ2, this is a very good way of looking at this question. When you give a senolytic to someone, how much does the biomarker go up? Because indirectly, it'll tell you how many senescent cells were killed. If it goes up a little bit, that probably means you didn't kill that many senescent cells. If it goes up a lot, maybe you did. And then you can answer questions like that. Now, that biomarker was only reported last year. So it's early, but I suspect there's going to be many studies in the near future where people are looking at this biomarker in conjunction with senolytic treatments and asking exactly the kind of questions you're asking.
Dr. Michael Lasante came on my show early on during the pandemic. I don't know if you know who he is from the UK, but he's originally from Brooklyn. I know he went to school here in the United States. And he did a discussion on the show about the use of senolytics as a potential therapeutic for COVID-19.
Yeah.
And his assertion was, and please, this is not my words, they're his. So if I'm getting something wrong, correct me. That senolytic cells are the preferred cells for reverse transcriptase related viruses to take hold of and turn them into viral producing factories. So the more senolytic cells you have in your body, the greater the viral load will be, because you have more factories making the virus. And he used a couple examples. He talked about there was a cruise ship that was out in the ocean and wasn't let back in because they had such rampant case of COVID-19 on it. And there was a husband and wife, and the husband was a kidney transplant recipient who was taking Cimarron, what do they call it? It's called rapamycin, but they also have another name for it. I want to say Cimarron or
sirolimus.
Sirolimus, thank you. Yeah. And so the husband was taking sirolimus, and while he tested positive for COVID, he was better in 6 hours. And his wife had to be left behind on the ship and hospitalized for like 2-3 weeks before they could get off the ship. And Lasante pointed at that and said, here's an example of a guy who's on very high doses of rapamycin for rejection, kidney rejection.
Yeah.
As a result of this guy has virtually no senolytic cells in his body, and therefore the viral load was so low, he ran like a low-grade fever for 3 hours. He felt a little bad for 3 hours, and then after that, he was completely better. And so what is this? What is this a theory? Is this really accurate that senolytic cells become hostages to some of these viruses that use the reverse transcriptase pathway?
Well, that's very interesting, and the reason it's very interesting is when we found that 25-HC was a senolytic. You first pass the literature discovers that there have been a couple of reports that 25-hydroxycholesterol is involved with COVID. And so, in looking at those papers, what they report is that your levels of endogenous 25-HC were going through the roof as you were very heavily infected with COVID. And so that would suggest that there is a compensatory response, and that compensatory response is being actioned on by your body somehow producing more 25-HC as a response to this viral load. Subsequent studies showed that 25-HC seems to be an actual viral inhibitor. It inhibits the replication of COVID-19. So there's increasing evidence that somehow 25-HC is implicated with viral infection, which would be consistent with what you just said. And so that then indirectly senescent cells may be playing a part in that story. But again, early days. We're not there yet. But fascinating sort of relationships there.
I'm going to plug the facility one more time. If you want to learn more about the Melov lab, go to shrnetwork.biz/Melov, MELOV. We're going to take one last commercial break, and we will wrap up the show. Stay tuned. We'll be right back. Being superhuman means being conscientious about the choices we make. White Oak Pastures is superhuman when it comes to raising livestock. They're committed to animal welfare, land regeneration, and rural revival. They responsibly manage the entire process from the pasture to your doorstep. High-quality, pasture-raised, great-tasting meat from a farm you can trust. Full nose-to-tail selections. They even have options for your pet. Go to shrnetwork.biz/whiteoak and use the code SUPERHUMAN to save 10% off your entire first order.
Dogs should be powered by fat and protein, not carbs. That's why Visionary Pet makes low-carb, ketogenic dog food for dogs of all breeds and life stages. From kibble to freeze-dried and even low-carb treats, all Visionary Pet recipes are very low-carb, ketogenic, and made with 100% real meat protein. Shop now and use code SHR for 20% off your first order today. Your dog deserves the lifelong benefits of optimal nutrition. Make the switch to Visionary and see why smart dogs eat low carb.
More than 240 million Americans take supplements daily in pill form, but poor nutrient absorption means the promised results are rarely achieved. Healthy Cell uses a clinically proven patent-pending gel delivery system that increases absorption by 165% over pill form. Go to shrnetwork.biz/healthycell. That's HEALTHYCELL today and use the code SHR to save 20% off your purchase of Healthy Cell supplements. Most people have heard of phytoestrogens, but did you know there are beneficial phytoandrogens? The top source of these is pine pollen. It even contains trace amounts of testosterone and DHEA. If you're looking for a 100% natural testosterone booster, this is worth trying. Lots of men love it, and it even works for women. Lost Empire Herbs offers the highest quality wild harvested, non-irradiated pine pollen backed by a 365-day money-back guarantee. It works for you, or you don't have to pay for it with nothing to send back. Go to shrnetwork.biz/lost empire. Use code SHR. Get 15% off your order today. C60, also known as Buckminster fullerene, is the most powerful, most versatile antioxidant in the world. It's been shown in studies to double the lifespan of rodents. We all know the importance of taking antioxidants to slow aging, reduce inflammation, and improve mitochondrial function and energy production. But there are literally hundreds of antioxidants that would cost you thousands of dollars to take every day. I take one. I take C60 from C360 Health. Revive and Rejuvenate are two blends that harness the power of C60. Don't waste another minute. Go to shrnetwork.biz/revive and use the code SHR for 15% off and free shipping inside the United States today. I would easily say that I am the hugest proponent you will ever meet to doing anything that will improve the quality of my sleep. And that's because sleep is linked to just about every metabolic disorder we see in our population today. One of the easiest things you can do to improve the quality of your sleep is to get a pillow that can be shaped into the exact form factor that allows you to get your best night's sleep. And that is MyPillow. I've been sleeping with MyPillow for a few years now, and I can tell you that when I have to travel and stay in hotels, I don't get a good night's sleep because I don't have MyPillow with me. Right now, you can save up to 60% off of everything offered to improve the quality of your sleep at shrnetwork.biz/MyPillow when you use the code SHR. Or you can call toll-free 800-889-4938. And remember to use code SHR to save up to 60% off of everything at their website.
This is the Superhuman Channel, where brawn and brains finally meet.
Welcome back. We're talking with Dr. Simon Melov, and we're talking about anti-aging, really. And that's, when this show first started out, within the first year and a half, I decided that anti-aging was an important subject because it seems to cross with the physical culture lifestyle. Those of us who love to train, I jokingly say that the way there's working class dogs, there's working class humans. And if we don't work hard every day, we start to develop neuroses and disorders and all sorts of stuff like that. I had a hunting dog. He was a Hungarian Vizsla, and his name was Theron. He was a wonderful dog, and I hunted with him all the time. I had a college professor who had an English short hair, a German short hair, I'm sorry. And we used to hunt together, but he didn't hunt with his dog near enough. I took Theron out every week. And if I didn't take him hunting, I took him to this big park called Forest Park in New York, and I just let him run until he was exhausted. Duke, the German short hair, developed all sorts of problems. Also, he was destructive. He would weave. He would stand there and just weave back and forth all the time. These are all the result of not working hard. We humans evolved to expend energy every single day. And the large majority of us, the most energy we expend is getting up from our chair at work and walking to the cooler to get a drink of something. This is wrong. We have to work hard every day to be healthy. That's my own opinion. But it became very obvious to me when some of the early studies out of the VA Medical Center and so on in California showed that there was a connection between how strong you are and how long you live. And this is something you can do. You can't change the color of your skin. You probably can't change your genetics, although epigenetics do have a big part to play. But you can change how much muscle you have on your body. You start now where you are, nice and easy, and move forward for the rest of your life. Because there was one study we talked about that showed that men past the age of 65 and women 60 who maintained the majority of their muscle lived the longest and had the best health outcomes. So that's really an important thing right there. Even if the senescent cell thing peters out, like the telomere thing, and you still have exercise. And exercise is just an artificial replacement for what we used to do as hunter-gatherers all day long. That's all it really is. With that being said, you mentioned NAD plus a second ago. Weigh in on it. What do you think about NAD?
Well, there's a tremendous amount of work in this area over the last decade plus or so, and I think the beneficial effects of it are not huge. I mean, you can point to many papers which have a lot of big claims associated with them, but in terms of the animal models, which is where probably the best quality data is, the benefits are not dramatic. They're good, but a lot of these things I worry about from the perspective of genetic diversity and sedentary animal models. You're fixing something which is broke, but you're not really improving something. It's a little bit like, in my view, caloric restriction shouldn't really be called caloric restriction. It should be called caloric optimization. It's what you're doing is you're just going back to what you were referring to earlier, our normal levels of food. When you overeat, bad things happen. And that happens a lot in mouse colonies, I tell you. The mice frequently will be like 50 grams. Now, a normal young mouse is about 30 grams, 25, 30 grams. But as they get older, they're just at an all-you-can-eat buffet all day, all long, and many of the males get up to about 50 grams. Now, that's an obese mouse, and we know that when you're obese, bad things happen, and that shortens your life. And the same thing we know from many studies in human beings, that optimizing your calories is beneficial to your health in the long run and maximizes your longevity. So I think a lot of the studies which show marginal effects, like 10%, 15% improvement in X, Y, or whatever, they might be fixing something which is broke in the mouse because it's an inbred model. It's eating all the time. It's not got a lot of exercise, and so maybe we should rethink how to do those animal studies. I would love to be able to optimize the mice so that they were kind of like elite athletes with a pristine diet, and some of the mice, most mice live to about 2 years, maybe 3 if they're lucky, but there are some species of mice which live 8 years, so that's a big difference, right?
Yeah.
But those are not the mice which are commonly studied. So it makes you wonder, are we studying short-lived strains of mice and then fixing things which are broke in them and then proclaiming a big breakthrough? I don't know, but it worries me.
I've said something similar on this show for years now, that scientists should be studying athletes, athletic types. Those
Yeah,
because you study sick people, you don't find out why they're sick. If you study athletic people who train, rest, eat appropriately, and they live the life of an athlete. You don't have to be a pro athlete. You could be an average slug like me. But look at us. We're aging better. Why don't you want to know why we're aging better? Scientists don't want to know that.
Well, no, that's not true. I think there's certainly a significant fraction of exercise physiologists are very interested in masters athletes. And there are many studies on masters athletes. The problem is exercise has not been very sexy. It just isn't, I mean, people don't want to put a lot of money into it. And the program we were talking about off air earlier, MotorPack, the molecular transducers of exercise, that's a big program. When that program is finished, we're going to understand how exercise confers its beneficial effects. And I think that's going to be a lot of breakthrough science is going to come out of that study. Now, that's approaching the end of its funding period. So I think the conclusions from that study are going to be coming out soon. And I think, someone from that program on your show would be a great interview for you.
Yeah, I want, now that you told me about them, that's what I'm going to do. I'm going to reach out to them, get somebody on here. Last question. Let's see what I did with it. Oh, Metformin. What are your thoughts on Metformin as a senolytic?
Well, as a senolytic, I don't know. I mean, the Metformin is a little bit of a poster child for a potential therapeutic for degenerative changes associated with aging, and how we think about it. That's at least how I view Metformin. The effects of Metformin itself in multiple animal models and human studies are not that impressive, especially when compared to exercise. I think Metformin in a head-to-head trial in diabetics with exercise was about maybe 20-30% as effective as exercise in terms of lowering blood glucose. So it's in my mind, if you're bringing an individual or a mouse or some model system up to an optimal level, which is epitomized by an exercised individual who is thoroughly at peak performance. And make no mistake, we can make people peak performance now very well. We understand how to make people perform really well from exercise and diet. And you only got to look at the world records in many, many different sports, and they're plateaued largely. I mean, you've got incremental gains in many of them because we understand so well how to optimize peak performance in human beings now. We haven't done the same in animal models, unfortunately.
Right.
So I think Metformin is good as a model for like paving the way for a potential therapeutic for degenerative changes associated with aging, but it's probably not going to be the end game in that respect.
I've been a vocal dissident when Metformin first came on the scene as a senolytic, and everybody was taking it because they thought it was going to stop their aging. They didn't pay attention to the reduction in protein synthetic response from its manipulation of mTOR.
Yeah, that's published now.
See, and I said this years ago. I said, yeah, you may live longer, but you're going to have to be in a wheelchair. Like, what kind of life is that? If you lose more and more muscle, you can't ambulate anymore. You can't move. You can't do. I'd rather die than be stuck in a wheelchair waiting for somebody to change my diaper, just personally. Yeah. And sure enough, I was just going to say, a study just came out that shows that it induces sarcopenia. Like, who wants to, we juxtaposed to what I just said about the importance of muscle tissue and longevity and health span, who wants to compromise their ability to build muscle tissue? I don't get it. But that was
it's still a little controversial, but I think that paper was pretty well done. And I think, the attractiveness of Metformin in many ways is because its toxicity is very well understood. It's pretty mild on the system. we know what happens to people who take it for a long time, which is nothing bad. So for many of the newer therapeutics, there's more risk associated with them, and sort of advocating them as a be all and end all for aging, than metformin, which is very safe. So a lot of the attraction for metformin is because of its safety profile, and not, I think, really for, if you take a really hard look at the data, the beneficial effects, particularly in fit individuals. You can make some arguments for people who can't exercise for one reason or another might be beneficial. And a lot of these arguments come down to the sort of the aggregate healthcare benefits across the population. And we know that a lot of the population is not very fit, certainly in the US and worldwide increasingly. So you can make an argument just on a healthcare sort of basis that in aggregate it would be good. So would a multivitamin.
Yeah, exactly. So a lot of things. So would a higher protein diet for most people who just eat carb-centric diets. Craig Hollander just posted this real quick, and we'll close on it. Inflammation, but not telomere length, predicts successful aging at extreme old age. And this is a longitudinal study of semi-super centenarians. And he also put the PubMed link up there, too, for those of you watching the show. So I think that pretty much puts a cap on the telomere discussion. All right, look.
Well, who knows? Like I said, it's fashion. So fashions come back. So
no, you're right.
Back.
No, you know what's going to happen? You're right. So science takes a particular topic to the extent it can at the time.
Yeah.
Then we learn new things. We have new ways of looking at things. And then all of a sudden we go, oh, wow. Like it could be that telomere length plus something else influences senescent cells. Then telomere length.
Absolutely.
Again. Yeah. Then it'll become important.
No, I think the good thing about science is we're testing it constantly with real world examples, and we're trying to forge, a better and more complete view of the universe, particularly with regards to health. Certainly in biology, that's what we're trying to do.
Yeah, fascinating stuff. I hope you'll come back when you have something new, please.
Sure.
Okay, it's been fascinating having you here. Thank you so much, Dr. Melov, for being here today.
No problem.
Take care. And that's it for today's show. We have a great show tomorrow and the rest of the week. I don't know what show we have tomorrow. I was focused on this show this week, to be honest with you. This is a fascinating show, and I hope everybody got something from it. Share the show, because you never know whose life you're going to change, and we will see you tomorrow with more Superhuman Radio. Thank you for being here today.